All right, using trig ratios to determine the measure of an angle, you need the worksheet, pencil, eraser, and your calculator. Calculator needs to be in degree mode. Easiest way to see if your calculator is in degree mode, at least for me anyways, is I just go, whoops, let's get out of that. I just go sine 30, because I know the sine of 30 is 1/2, so this is not in degree mode. So I go to mode, I go down here, I go to degree. Whereas basically, if you're doing one of those puzzle sheets, you're just not going to get any of the answers that are there, right? It's like, I'm just not getting any of these answers because your calculator's in the wrong mode. Quit. Okay, if I hit second function and then I hit the whatever key, this is kind of blown out, enter key, what it does is it brings down the last thing that I typed, right? So instead of me hitting sine 30 again, I can just go second function, enter, and it will bring back the last thing I input. It's a very handy thing sometimes because we got to repeat a calculation, maybe with a slight variation. So we can just go second enter and then edit the line. And I'll show you how to edit. 0.5, okay, it's in degree mode, right? Everything's good. Review. Label the sides of the following right triangle with reference to the indicated angle. Which side should we name first? The hypotenuse. And where is this hypotenuse? So, yeah, on the top here, right? So we label this and we say this is the hypotenuse, which is where? How do we know that's the hypotenuse? It's across from the right angle. Okay, then what's the name of this side?
Opposite.
Okay, so this side is opposite angle A, and this side is adjacent. And when we name sides, we do so with respect to an angle, right? And that angle is never the right angle. So with respect to an angle. So this is the key to trig, right? It's always just, okay, I got a triangle here, I got to name the sides. Once I've named the sides, then I can figure out what's what. Given the following triangle, determine, what does determine mean? Show your work. Good. See, you've learned something. It's been a couple days. Determine each of the following as a ratio and as a decimal rounded to the nearest hundredth. Okay? So, sine, what's the formula for sine? Opposite over hypotenuse. Which of these guys? Okay, we're talking about angle A. So what is the sine in terms of the numbers now? 5 over 12. That's a ratio. And I don't like stringing equal signs across, but I don't have much room. So as a decimal to the nearest hundredth, it is to the nearest hundredth. 0.42. Okay, you gotta get used to rounding. 0.42. What's the easy way to round if you're lazy and on the calculator set mode, right? Because so if I know I'm doing 6 of these guys and I got to round and I'm not really great at rounding, then I'm going to go to mode and set it to 2 and let the calculator do the work for me. Right? Okay, what is the cosine of angle A? Adjacent. And what's the measure of the adjacent? Yeah, we don't know this, right? Okay, we're missing something here, right? So one thing, before we started this, we could have said, hey, look, if I'm going to do sine cosine, I need all 3 sides, right? Because it's opposite over hypotenuse or adjacent. So I need this side. So what is this side?
10, 9, 9, 0, 8, 7, 1, 2, 1, 1.
How are we going to calculate this side? We're going to use the Pythagorean theorem, right? And what are we going to say? So, I'm sort of tempted. I might just sort of squeeze it in here and say that, well, what's the name? Okay, let's call this C, I guess, right? Just for the heck of it. Then what's the name of this side letter name? What's the letter name here? B, right? This is C, this is A. Okay, because we name the letters with the lowercase letter of the side which it is opposite, right? So opposite angle A, little a. Opposite This has now been named C, because you could have named it anything. But okay, so what can I say, right? I could say that a squared plus b squared is equal to c squared. We do that up here. A squared plus b squared equals c squared. We know little a, so 5 squared plus, we don't know little b, that's the unknown, right? B squared is equal to 12 squared. So b squared is 12 squared minus 5 squared, which is 144 minus 25, which is 119. So b is the root of 119. Well, it says to round things to the nearest hundredth, right?
10.191.
However, we know that when we're doing calculations, we only round when? The final answer. So we're going to use root 119. Okay. So what's the cosine of angle A? What's the formula for cosine? Adjacent over hypotenuse, right? I have to write that down. If I write that down a couple hundred times by the end of the unit, you think that when I sit down to write the test, I'm going to have a problem when it says sine theta? Probably not. And if I do, then among the least of my worries, because I'm not going to know anything. So write it down every time, right? What's the secret to math? Formula, substitution, answer. And then check stuff over. Okay, adjacent. What's the adjacent side? The root of 119 over 12. Okay, and now you can work that out as a decimal rounded to the nearest hundred. 0.91. Tan A. What's tan A? What's the formula for tan? Opposite over adjacent, right? Okay. What's opposite A? 5. What's adjacent to A? Root of 119. What is 5 divided by root 119 rounded to 0.46. Okay. Any questions to this point? Okay. So we have sides of a triangle. We got 2 out of 3 sides of a right triangle. If you know 2 out of 3, you know all 3. You got to go through a little bit of a calculation, but you get the third side. Now we know all 3 sides. The ratios rely only on the lengths of the sides, so boom, we got them. We're not asked for the angle, right? Nobody said, what's angle A? They said, what's the sine of A? What's the cosine of A? What's the tangent? What's the sine of B? What's the formula for sine? Opposite over hypotenuse. Good thing it didn't change, right? It's still opposite over hypotenuse. Which is? Over 12. What doesn't change when we're talking about sine A or sine B or what's constant? Which number is always the same, no matter which angle we're talking about? Is opposite always the same? No matter which angle we're talking about? Is adjacent always the same, no matter which angle we're talking about? What's always the same? The hypotenuse is always the same because it doesn't depend on anything other than where the right angle is. The right angle can't change position, right? When we talk about angle A, we're talking about this angle. We're talking about angle B, we're talking about this angle. When I talk about angle A, this is opposite, this is adjacent. When I talk about angle B, this is opposite and this is adjacent. Whether I talk about angle A or angle B, this is the hypotenuse. The hypotenuse will always be 12. Opposite and adjacent change depending on the angle. Okay, what's root 119 divided by 12?
It's the same as cos.
Ah, yeah, we know that from before, eh? That the cosine is the sine of the complementary angle, and now we know that complementary means that they add to 90 degrees, and we know these two angles have to add to 90 degrees, right? They're always complementary because the triangle sum theorem says that these 3 angles add up to 180, and this guy's 90, so the other 2 must add up to 90. Okay, what's the cos of B as a ratio? Oh, first of all, what's the formula for cos? Adjacent over hypotenuse, which is 5 over 12, which is Right, which we already worked out, right?
Yeah.
So, okay. Saved a little, right? Saving some time. Tangent of B, what's the formula for tangent? Opposite over adjacent, which is, in numbers,
This, the root of 118 over 5.
which is, and this time you actually have to work this out, right? So what does it work out to, sorry? 2.1, what? 8. Okay, so this guy crossed over to this guy, right? And this guy crossed over to this guy. Because cosine is the sine of the complementary angles, and we know angle A and B are complementary. But so when we worked this out, I said, well, we already have that. It's down here. We worked this guy out here. Well, we already have that. It's up here. When we work this guy out here, it's actually the reciprocal of that. We don't have it worked out, so we need to do that. Not that it's all that onerous a task, right? Okay, questions on this particular section? I'd say page, but for you, oh no, there's more. Use any of the ratios above to determine the measures of angles A and B. So how are we going to find angle A or angle B? So to find angle A, which ratio would you like to use? Sine, cosine, or tangent? Tan. Okay. So we're going to say what? We're going to say the tan of A is equal to 5 over root 119, right, which we're just pulling off of here. So what's A equal to? What operation do we have to do? We need to do the tan inverse. Right? So we got to go second function tan 5 divided by root 119 and hit enter, which gives us. And I don't know, let's go to the nearest hundredth just because they didn't say. 24.62 degrees. Now, there are some amongst us who might have said, hey, if I use the sine of A, I don't have to punch in a root sign, right? It's just 5 over 12. Nice, easy numbers. So they may have said, hey, sine of A is 5 over 12, so how do I unsign something? Sine inverse 5 divided by 12. Okay, what's the inverse sign? So go second function sine 5 divided by 12. What do you get? You better say the exact same answer.
24.62.
What? Yeah, the exact same answer, right?
Yeah.
You never try again. Keep trying until you get 24.62. Okay. So, what are we going to use for angle B? Because we're lazy and we don't want to type a root sign. What are we going to use? Which one doesn't need a root sign? Cosine. You could also just go 90 minus this number, right? Because we know they add to 90. But we need practice doing, So we're going to say, okay, the cosine of B is equal to 5 over 12. So B is equal to, what do I write now? What do I write right now? Cos inverse, which is?
65.38.
No huge shock, right? I could actually have calculated it in my head. I had the 0.38 down, I just wasn't quite to the 65. Because we know they have to add up to 90, so, if you had, but it said use the ratios, and it said determine, and determine means show your work, and if I said use the ratios and determine, then showing it another way, it would say, yeah, you're right, but you got 1 out of 2. Okay. Why? Because you didn't use the ratio. Oh, but come on, I knew that. Like the key. As I look at the key, which has been posted, I note that there are no degree symbols on these, and I'm sort of shocked because she usually does better work than that. But all right, they should be there. They're not there. Fair warning, right? Write them in yourself if you print them off. So one thing you can do, of course, right, is you can print all of these off. Like I may not save this. This is just my lousy writing, right? It's already up there. Okay. So the notes are, but what happens is, you know, if you miss less, if you watch this video, you'll see the sheet being filled in, right? So if you've got the blank sheet at home because you're away today, then obviously you're not listening. You know, you're getting the live version. But you can watch this, right? It's just all going to be filled in before your eyes. Okay, questions? Good so far? So everybody can do ratios. You can do them as exact values as a ratio and then convert it to a decimal. You can round correctly. And you can, given a ratio, you can calculate the angle from the ratio. Angles of inclination, elevation, and depression. Inclination and elevation really kind of the same. An angle of elevation is the acute. What's acute mean? That's the 90 degrees. The acute angle between the horizontal and the line of sight to an object above eye level. In other words, you're looking up. You're looking up, and how you want to measure that angle is so basically you're looking at a horizontal line at eye level. Okay? So I leave that there, and then I look up, and this is the angle of elevation, right? In between here. Okay, and if you're listening to this on video, tough. Right. So it's just a horizontal line basically coming out of your eye, and then you measure the angle up. So, you know, technically speaking, I guess on here, really, that's your angle of elevation. This is just another distance. So if I need to figure out the height of something, I would have to add that distance on. If it's high enough, this really doesn't make any difference, right? So. Okay, but you know, if you get a question, you know, John, whose eye is 1.7 meters above the ground, is looking up to the top of a tree and all of that, then you'll draw that, and this is your angle of elevation. Angle of depression, looking down. So you're at the top of a building, or you're in a hot air balloon, and you're looking down. Again, measured from a horizontal, right? So basically what you do is you draw a horizontal line coming out of the eye, and then angle of elevation, you've got the angle up. Angle of depression is the angle down. Okay? If there's somebody else here, right, this is the line of sight. If there's somebody else here looking up at you, what do we call this angle? That's the angle of elevation. What can you say about the angle of elevation and the angle of depression? They're equal. Yeah. Do you guys study that thing? You've done like parallel lines and transversals? Yeah, okay. So this is like that Z shape, right? It's not like, it is a Z shape. Right. So these two angles are equal. Does that make sense? It makes sense. If you're looking down at an angle of 30 degrees, then somebody else is going to have to look up at an angle of 30 degrees to see you. So those angles are equal, okay? That could be kind of a handy thing when you're solving the problems, right? Like, I know this angle, but boy, it'd be a lot easier to work stuff out if I knew this angle. Okay, wait, I do know that angle. Okay, any questions on elevation, depression? Yes?
So they equal each other all the time?
Always. Yeah. Because these lines are parallel. Remember, your line of sight, your horizontal line, by definition, horizontal is on right. Those must be parallel lines, and then this line is a transversal, and these angles are equal. Okay, by some theorem. Okay, we are going to do a number of examples where I think that number is 4, but we'll start with one. To be safe, a ladder should have an angle of inclination of about 75 degrees. A 14-foot ladder is placed against a vertical wall such that the foot of the ladder is 3 feet from the wall. Is the ladder in a safe position? First step. Draw a picture, right? I mean, I don't know about you, maybe you can imagine what I like to draw a picture. I like to label it. Okay, ground, wall, ladder. Wall perpendicular to ground, therefore 90-degree angle. Ladder is, do we know this distance?
Yeah.
What is it?
14.
This distance? 3. This, that's the angle we're interested in, right? That is the angle of inclination, right? Because it's measured from a horizontal to the ladder. Okay, so from a horizontal line to the ladder. So inclination, I guess, is probably used when we're talking about an object and elevation. Elevation and inclination, basically, fairly interchangeable, right? Usually elevation, you talk about somebody's looking, though. It's an observer. What do we need to figure out? So, what do we need to do? Okay, what do we need? So, George Polya, a Hungarian mathematician, came up with a 4-step problem-solving method, right? And nobody's improved on it since. So, here are the 4 steps. Step number 1 is understand. Understand is usually, okay, what information am I given? What do I have to find? Okay, so like, what do they give me? What do I have to find? Step 2 is to plan. Okay, what am I going to do? How am I going to solve this? Step 3 is to do. So I'm going to carry out the plan. And step 4 is to look back. And looking back is, okay, does this make sense? Did I do stuff correctly? Have I solved the problem that I was supposed to solve? Or did I end up finding something that I really didn't need to find? Right, that's looking back. Okay, so 4 steps. So understanding this problem basically comes with sort of, let's draw the diagram, let's put the information we have. So what information do I have? I got a 14-foot long ladder whose base is 3 feet from a wall. It's leaning at some angle, I don't know what. I got to figure out what that angle is. That's the angle of inclination. If it's about 75 degrees, then I will say yes, the ladder is in a safe position. If it's not, then I will say no, it is not in a safe position, right? Okay. So we understand it. We got a plan. Okay, so what do we do? So let's name the sides. In relation to the angle theta, what's the name of this side? Okay, that's adjacent. In relation to the angle theta, what's the name of this side? Really, that's just the hypotenuse, right? It's got nothing to do with theta, but okay, so hypotenuse. Which trig ratio do we use if we have adjacent and hypotenuse? Cos. Okay? So here's how we do right triangle trig, right? We draw a picture, we label everything on there, and then we figure out, okay, what am I supposed to find? I got to find an angle. What do I know? I know adjacent and hypotenuse, okay? Which tells me I'm going to do what? I'm going to use the cosine, right? So I'm going to set this up, and I'm going to say the cosine of angle theta is defined as adjacent over hypotenuse. So the cosine of angle theta is equal to 3 over 14. How do I uncosine something? So theta is the inverse cosine of 3 over 14. Really what you're doing is you're doing the cos inverse of this, and you're doing the cos inverse of this. The cos inverse of the cosine is just the thing, right? Because you're uncosing it. There's no such word, just so you know. But that's effectively what you're doing, right? And, okay, so what's the angle? 77.63 degrees. So, anybody see Marathon Man? Is it safe? Yeah, okay, it's safe. Anybody see Marathon Man? No? Okay. If you ever watch the movie Marathon Man, there's a big line in it. Is it safe? It is safe. Questions? Comments? Concerns? Moving on. Determine, which means what? Trig order. The measures of the angles between the diagonal of a rectangle and its sides, if the width of the rectangle is 3.4 and the length is 8.1 centimeters, round to the nearest 10. Okay, what should I do first? Draw the diagonal. Okay, where will I draw the diagonal? Okay, so from the upper left to the lower right or the other way? Doesn't matter. Any particular choice? Do you want me to go here or here? First one or second? First one? Okay. Does it matter? So draw a straight line. No. Nope. That'll do. And I can mark those as 90s, right? Because it's a rectangle, therefore it's got right angles. Okay, what else can I do? Okay, so I want to write down 3.4. Where am I going to write it? Left, top, bottom, right. On the left. 8.1, left, top, bottom, right, or diagonal. actually put it all over the place, right? At this point, we don't need units because this is math. We're not big on units until the end, right? In science, they may tell you to put units in this other. You could put the units in here. That would be fine. Right? It's no big deal. What are we supposed to find in this thing, anyways? Determine the measure of the angle or the angles between the diagonal rectangle and its sides. Okay, so what else do I have to label here then? Find those angles, right? So determine the measures of the angles. So it's plural, right? So there's more than one. But once we find one, what are we going to do to get the other? Go to 90 minus, right? Okay. We don't need to use trig. But I didn't say, right? The other one said use trig ratios to, okay, then I have to use trig ratios, right? This one, if we find x, we'll calculate y. What are we rounding to? Nearest tenth. Good enough. Okay? Right. So I think we understand it now, right? So now we need a plan. What's the plan? Use trig. Okay, so the plan is to use trig, right? Okay. And what are we going to use? So what are we going to figure out? Which one, x or y?
Doesn't matter.
Doesn't matter. So pick one. X. Okay. So then what we do in solving trig, so now we're just going to ignore basically all of that, right? So we have this triangle here. This is x. This side is named opposite. This side is named. The ratio which relates opposite and adjacent is. So we are going to write the tan of x is opposite over adjacent. The tan of x is, and now we're going to put the numbers in, right? X is equal to, the operation you're going to write down is, what do I write next? I don't want the number, I want the next step. The inverse tan, right? Get used to it. You're about to show more work in 1 week of grade 10 math than you showed in an entire year of grade 9 math. Unless your teacher made you show lots of work. In which case, good for them. So show the work, right? I mean, this just, you know, it shows everything, right? Okay, what am I doing? Well, anybody looking at this can say, all right, there's a diagram, there's information on the diagram. There's some unknown thing, and there's these guys, which match up with this information. Oh, look, and they've said this is opposite and adjacent. Now they're telling me that they're going to use the tangent ratio, which is opposite over adjacent. They've substituted in the correct values. They're now showing how to get that, and the answer is? How much, sorry? What's the number? 22.77. So should we call that 22.8? Because we only want... Okay, 22.8. And we put units in, right? Degrees. Okay, and now what's y? So I really shouldn't have crossed everything off there. So. Yes? No? I don't know. I did it in my head, so it's hard to say. Is it? Okay, good. I do stuff in my head, so you got to check, right? I don't know. I think they add to 90. Okay, I didn't really show any work for this. So maybe I want to show something like, let's say x plus y is equal to 90 degrees, and 22.8 degrees plus y is equal to 90 degrees, and so y is equal to 67.2 degrees. Right? I'm likely to let you get away with that. It's kind of, you know, really, I can't. You know, you labeled it, and maybe you throw this in too, right? There. Look, it's a right angle, right? Now it says, look, it's a right angle, so therefore, if I do this, you know, really. Go on, Mr. Hanover, I thought you were bright enough to figure that out, that I didn't have to show that. Oh, any questions on that? Too bad, it's gone. Okay, number 3. Ask sooner. If you have questions, make sure you interject. On one part of the bicycle pathway along 14th Street in the Northwest, a cyclist travels a distance of 1 kilometer along a pathway while gaining 80 meters in elevation. Determine the angle of inclination of the pathway to the nearest hundredth of a degree. Okay, what should we do first? Draw a picture. Okay, you draw a picture. I'm going to pause this. Now I got 1 kilometer and 80 meters. What do I want to do then? Either make the 80 into kilometers, which is too much work for my brain, or make the kilometer into meters, which I don't even have to think about. It's 1,000 meters, right? And somewhere on here I need an 80. Where? So, there. And that's going to be theta, right? That'll be the angle of inclination. So, does your diagram look something like that? Although you might have a 1 on the bottom and 0.08 on the side, right? If I did the math right, I don't even know if 80 divided by 1,000 is. Your choice, I don't care. Doesn't matter, right? But they need to be in the same units, right? You can't have 1 kilometer here and 80 meters here, right? You're not going to get the right answer. Okay, so I think we have understood the problem. We got a plan, use trig, okay? And which ratio are we going to use? It's always the tangent. In real life, it's almost always the tangent ratio, right? So Mr. Earhart said that. Mr. Earhart teaches math. In addition to that, he teaches construction. And he worked construction. He said, you know, really, in the real world when you're doing stuff, you know, you can almost always measure this and this. Very rarely do you need this, right? Remember, we have to make up questions where you need this. Right? Oh, there's a kite flying, and how long is the kite line, right? Because it's like how high and how far away is it? Stuff is easy to measure. But so you know, often in real life it's a tangent. So if in doubt, use tan. You might get it wrong, but you know, you have to guess. All right, so we're going to say tan theta is, and we can call this one's opposite and this one's adjacent. So tan theta is opposite over adjacent. Show the formula. Tan theta, substitute 80 over 1,000. Theta is the inverse tan. All right, so the nearest hundredth, theta is? How much? 4.5. Really?
Yeah.
Wow. You got this wrong. I'm taking back that evaluation I gave. 7? You sure?
Yeah.
Wow. All right, there's another mistake on the sheet. 4.59. Oh. Oh. Yeah, no, she drew the diagram wrong, that's why. She put the 1,000 along here.
Yeah, that's what I did at first.
Well, okay, wait a sec. So, yeah, maybe should the 1,000 be there then? Yeah, I think you're right. Yeah, okay. We'll go with that. See, because she's seldom wrong and I'm seldom right. So, yeah, because then this would be the pathway itself, right? Okay. So that thing I said about always being tan, yeah, not always. Okay, so that's hypotenuse. That's why didn't you fight for it? Hey, remember, I think the 1,000 should go on. You guys have no self-confidence, don't they, right? Come on. Everybody's been telling you till now that you're great, so you know stuff. Just say, isn't the pathway the thing that's going up? Right? So I'd say I did that on purpose, right? Put it in the wrong place. They say, wait a sec, that's not the pathway. Okay? That's the pathway. Okay, sine theta. Theta is the inverse sine. So what is it?
4.59.
It's so close that it almost doesn't matter, right? Because one number is so much bigger than the other that, you know, like, so if that was 1,000, this wouldn't be that much more than 1,000, because that's only 80. And if that was 1,000, then this would, you know, that would be a little bit more. And if that's 1,000, that's a little bit less than 1,000, but not much. All right, that makes sense. So, lesson number 2, call me out. No, I don't think that's the right diagram. I think the pathway goes along there. Yeah?
So just to clarify, you use sine, cos, or tan depending on what equation
Yeah, so you look at the angle, right? And you say, what have I got? So in relation to that angle, I have opposite, I have hypotenuse. Which ratio do I use for opposite hypotenuse? Okay, I use sine. So right out, sine theta is opposite over hypotenuse. Okay. Then I fill in the numbers. Then I say, but it's theta I need to work out, so I need the inverse sine. Right? And then we go. All right? It's going to be this mildly embarrassing YouTube video up of there, me doing the question wrong, but yeah, we'll fix it. Hey, that's how real math happens, right? You mess up, and then you look at it, and it's, oh, yeah, wait a second, that's the pathway. All right. Okay, a new tree is planted in the ground. This time I'll look at her key first. I get it right. The tree is to be pegged to the ground with two 4-meter-long ropes that are attached to the tree 2 meters above the ground. So you've all seen that, right? You've seen trees being planted, and they put little, ropes down to hold it in place while it, gets its roots going. Determine the angle of inclination between the ropes and the ground. Wow, sine again. So a new tree is planted. Trees be pegged with two. So here's the tree. Here's the ground. With two 4-meter-long ropes. Okay, that's 4 meters long. They're attached to the tree 2 meters above the ground. Okay, does that seem reasonable? Did I mess up again?
And then is the bottom
And I don't know, what are we supposed to find? Determine the angle of inclination between the ropes and the ground. So we got to find this. Okay, seem reasonable? Yeah? Sure? I'm going to start throwing stuff out there that I know is wrong. Okay, so in relation to theta, name. Opposite, name. Ratio. This first thing I'm writing down there is communication, right? And the key to you being successful in life is communicating. If you didn't have to communicate anything, then really, why are you here? Because, unless you're planning to be like a hermit in a cave type thing, in which case, cool, you don't really need to communicate much. You can sit and contemplate. But mostly we're communicating with other people, right? We want to communicate clearly, concisely, right, and correctly. So this communication is saying, well, this is saying, here's a diagram which should match this situation, right? So you look at that. Okay. That's what I want to find. I'm using opposite or hypotenuse. I'm using the sine ratio because I know the opposite and hypotenuse. If you want to, you could label this as opposite and hypotenuse. Okay, now I'm going to fill in some numbers. So sine theta is 2 over 4. So theta is the inverse sine of 2 over 4, and theta is 30 degrees. I knew that because it's a half, right? And if there's one number that's exact, right, the one number everybody knows is that sine of 30 is a half. And from that comes everything else. Right? Like there's a whole pile of numbers you're going to have to know in grade 12. Just start with sine 30 is a half, and trust me, everything else just flows from that. There are some other numbers you need to know, but they'll come out of sine 30 is a half. All right, there are some other examples in the textbook, so this implies you might want to look at them. Okay, so they'll be worked out. So what do, right? So you get home, you have a problem with something, or you look at examples, right? That's basically how, we do a lot of this stuff. It's like, look, here are some solutions to some problems. You get a different problem, you look and say, well, it's like that problem, right? Here's what I've got labeled. What do? I got to look through this. I got to figure out the information, right? Like, where's the angle? What are the names of the sides? Which ratio do I use? Okay, I'm using this ratio. I filled in the numbers. This is what I'm doing is the inverse sine. This is the operation I'm going to do. This is the answer I got. Oh, and really for all of these, you should say the angle of inclination. Because they're word problems, and word problems really deserve an answer to the question. Determine the angle of inclination. The angle of inclination is 30 degrees. Right? Now we'll go, whoops, move the frame. Come on. Go. Fine. Get it here. Put that back. Okay. This one here should say the angle of inclination, right? So there should really be a statement at the end of each of these. I'm going to go back to the other two. The angle of inclination is 4.59 degrees. Okay, this one is, right? It is safe. And I think that one's good enough, right? Because the diagram relates back to this. You know, I mean, you could say the angles between are, but, you know. And then here, really, we should answer this, right? The angle of inclination. Really, it should be the angle of inclination of the pathway of the pathway. And the angle of inclination of the rope. Okay, questions, comments, concerns?